Go ahead and we'll move on to post-lab. So after we go through calculations, we move on to post-lab questions. So for this lab notebook sheet that kind of explains, we have post-lab questions. Not every lab has post-lab questions. If it does, so this lab handout has post-lab questions on the back. If it has post-lab questions, we have to answer those questions. Now, with these post-lab questions, you do not have to restate the question. You don't have to rewrite the question, just answer it. So I'm going to label this section post-lab questions. And on the lab handout, there are just 3 post-lab questions. So the first post-lab question says, explain the term reaction rate. And then what are 2 ways to make the reaction occur at a greater rate? So we're going to talk about reaction rate much more when we get into kinetics, which is later in the year. But for now, we can just think about reaction rate as speed of the reaction. So reaction rate is the speed of the reaction. So it's how fast a reaction will go. Now here's what I want us to think about as we think about ways to increase the speed of a reaction. If I have, let's say I want to dissolve sugar into coffee. What is one way that I can make the sugar dissolve faster? Right, heat up the coffee. So one way to increase the speed is to increase the temperature. So we can increase the temperature and make it dissolve faster. If you put sugar into coffee, if you just put the sugar in, let it sit, it's going to take a while to dissolve. What's another thing I could do to make it dissolve faster?
Stir it.
Stir it. So another way is to stir it. So if we wanted this reaction to occur at a faster rate, you guys just put the penny in and allowed it to react. One thing we could have done is we could have sat and constantly stirred. That would have made it occur at a faster rate. Or we could have increased the heat of the acid. Might have not been a great idea, but we could have done that. Okay, pre-lab question number 2. What was the purpose of rinsing the penny with ethanol on day 2? And it says acetone would have also been good. So the point of rinsing with ethanol is that ethanol stopped any further reaction. Ethanol also evaporated pretty quickly, so it allowed our penny to try to get as dry as possible. And then finally, post-lab question number 3. Write the net ionic equation for the reaction between zinc and hydrochloric acid. So if we look at our pre-lab questions, and what I'll do is I'll put the pre-lab questions up here because we have a different lab notebook. So here was the reaction that we wrote in the pre-lab. So I'm going to rewrite that reaction to start. So solid zinc plus 2 HCl, which is aqueous, yields ZnCl2, which is aqueous, plus H2 gas. So this is the molecular equation. Molecular is the overall balanced equation. Now this is going to want our net ionic equation, which means I have to break apart any strong electrolytes. Strong electrolytes are one of three things: a soluble ionic substance, a strong acid, or a strong base. I'm going to show you. So strong acids. Let's go through the strong acids first. There are 7 strong acids that you need to know. They are HCl, HBr, HI, HNO3, H2SO4, HClO3, HClO4. Right, those are your 7. The bases are a little bit easier because they make a lowercase b on the periodic table. So I did this in pencil, but see, lithium down, calcium down, makes this lowercase b. So any of these metals with hydroxide is a strong base. So LiOH, NaOH, KOH, CaOH2, SROH2. Those are your strong bases. So really just the 7 strong acids you'll need to memorize. So let's take a look at this. Remember that an electrolyte is an aqueous solution. Right? An electrolyte is an aqueous solution. So the only thing that I could potentially break apart is anything that's aqueous. So zinc will not break apart. H2 gas will not break apart. HCl has the potential to break apart. Is HCl, so it's an acid, is it a strong acid? Yeah, it's one of the 7 strong acids, so that's going to break apart. I'm just going to put an arrow down so I remember to split it apart. Then, ZnCl2. So that's an aqueous solution. I put AQ over here. When you guys were pulling the shell out of the beaker, you had a clear solution. That was the zinc chloride solution. So aqueous, if it's aqueous, it needs to be ionic, strong acid, or strong base. This is a metal. That makes this ionic. If it's ionic and aqueous, it's a strong electrolyte. It's going to break apart. So I'm going to rewrite everything down here. So Zn solid, because that stays together. I'm going to split apart HCl. Split it apart into its ions. Make sure it stays balanced. So the 2, the coefficient, goes to both. So 2H plus 2Cl minus. And then I guess I can put aqueous. All right, zinc chloride will split apart into its ions. So Zn2 plus and 2Cl minus, because don't forget to take that subscript into account, and then just H2 gas. So that's the complete ionic equation. That shows everything. To get to net ionic, we have to cancel out spectators. Cancel out spectator ions. What is the exact same on the left and the right? Has to be an ion. It's a spectator ion. If I look here, I have Zn solid, Zn2 plus. That's not the same. One is solid, one's aqueous. I have 2H plus, which is aqueous, and H2 gas. That's not the same. 2Cl aqueous, 2Cl aqueous. That's the same. So 2Cl minus. Those are my spectator ions. So now I'm just going to rewrite this equation. There is the net ionic equation. That's our answer to number 3. So those are the post-lab questions. If the lab has post-lab questions, you'll answer them. If not, you don't have to worry about it. Now, the next section of the lab report is usually the most difficult as we start labs. And this next section is called the data analysis. The data analysis is essentially the results section, the discussion section, where we summarize what we did, we discuss what we found and what that means, and then we also talk about sources of error. So we are going to write this data analysis section together. So I'm going to label the next section data analysis. And then I'm going to go ahead and I'm going to start the data analysis. Now, if we look at this lab notebook sheet, this is a detailed discussion of the results. We want to summarize what we found, add any important data or observations, and then we also want to make sure that we talk about sources of error. So sources of error get put into the data analysis as well. So we're going to go ahead and we're going to start writing the data analysis. And what I'm going to do is I am going to be leaving blanks in the data analysis for you to fill in. You can write this word for word exactly how I write it, but just fill in the blanks with your data. So let's start by summarizing what we did. In this lab, we filed a penny. In parentheses, I'll put post 1982 to expose the zinc inside. So we filed the penny, so you had your lab partners do this part. They filed the penny, and we'll say the mass of this filed penny was over many grams. So fill in what your mass of your filed penny was. So look back in your data and observations. Right, so that's the mass of your filed penny that's going to go there. Then we're going to say the penny was placed in a beaker with excess 6 molar HCl. So I know that when your lab partners started, the Wi-Fi was being super finicky, and so it was hard for you guys to actually see what was happening. But we're going to write down the observations that they saw. So we observed bubbles, which told us a gas, we know now was H2, was being formed. Right, so when you see bubbles, that tells you that a gas is being formed. Okay, so then we'll say we let the penny react overnight. And the next day, we observed a copper shell. So now this is what you guys saw. If you saw other things besides the copper shell and you want to add that to this sentence, that's fine as well. But we are going to say the copper shell had a mass of whatever your mass was, blank grams. I'm going to say based on our data, we found the percent of copper to be blank percent. So this percent of copper was calculation 1. So for these blanks, we have the mass of the filed penny, the mass of your copper shell, and then the percent of copper that we calculated in number 1. That's it in terms of summarizing what we did. This wasn't a very long lab. There wasn't a lot of data and observation. So this summarizes the lab itself. The second part of the data analysis deals with what we call error analysis. So we're looking at possible sources of error. How do these sources of error affect the data that we collected and then the calculations that we did? So I'm going to start the second part of this data analysis by saying possible sources of error include, and I want to think about different sources of error that we might have. So I'm going to think about 3 of them. You usually only ever need 2 sources of error, but I want you to start thinking about how error can affect the lab, because AP has started to ask more and more questions about how sources of error might affect labs that we're doing. Now, when it comes to sources of error, lab partner does not count as a source of error. So we can't use human error as a source of error. Instead, we want to think about what happened in the lab that could have actually affected what we did. Did something spill? Was something still wet? Things like that. So I'm going to think about 3. Again, you usually only ever need 2. So one of the sources of error, so include the zinc not completely reacting. Oh, that should be a comma. So for some people, they actually found that they still had like black particles around their copper shell. That was zinc. There were some people that accidentally ripped it open or purposefully ripped it open and still saw that there were black particles inside the shell. That is zinc. That is zinc that did not react. That's a source of error because we assumed that all of the zinc was gone inside the copper shell. Right? Another possible source of error is that we had to let the penny sit and dry for 10 minutes. Well, what happens if the penny still had water inside, right? The shell still had water inside that we didn't see? So another source of error would be finding the mass of the CU shell while still wet. Right, so that's the second possible source of error. And the third one that I want to think about, again, you usually only ever need 2, but I want to get us thinking. The third one, and this didn't necessarily apply to everyone, and these sources of error are not necessarily like what happened to you specifically. Because some people are like, I did my best to not have any sources of error, and they get really low percent errors. This is just thinking about what could have happened. So finally, the third one that I want to think about is what happens if somebody picked up the copper shell and it ripped in half? Well, if the copper shell ripped in half and some was lost on the lab table or on the floor, that's a possible source of error. So we have the zinc not completely reacting, finding the mass of the CU shell while still wet, and losing some of the copper shell if it ripped, right, or tore. So I always just want us to think about what could have happened. Now the last part of the data analysis is to actually think about what this error would have done to our calculations. So I'm going to pick 2 of them. I'll pick the zinc not completely reacting. So I'm going to say if the zinc was not all reacted. So let's think about what that would mean. This is the same as if the shell were wet. If the zinc were not completely reacted, there was still some zinc inside that copper shell. What would that actually do to the mass of the copper shell? When you put it on the scale, if there was still zinc inside, it would increase it. So if the zinc was not all reacted, the mass of the shell would be too high. Now, if we actually look back at our calculations, the whole point was to do percent composition, percent of a penny. If we look at our mass percent, I'm just going to put it up here for you. If we look at this calculation, mass of Cu shell, if this number were too high, and even look at your calculations, if instead of 0.05 grams, it was 0.5 grams, that's going to make your overall percent too high. So the mass of the Cu shell would be too high. I'll just put a comma, which would make the percent too high. So we want to actually think about how that error might affect it. Okay, let's talk about error analysis for a second source of error. So let's say if some of the Cu shell was lost, let's say if it fell apart, the mass, so if some of the copper shell fell onto the lab table or fell onto the floor, you went to take the mass of the copper shell. Well, if some is on the lab table or the floor, what's that going to do to the mass when you put it on the scale? Going to be too high or too low? Too low. The mass of the shell would be too low. Again, look back at your calculations. If that top number is too low, then your percent's going to be too low. So this would cause the percent to be too low. There's our data analysis. This is the most difficult part of any lab because it requires you to summarize, think about what you found, think about sources of error. Okay, and then the very last thing, and I think I'm going to be able to fit it down here, is the conclusion. Now, conclusion is short, sweet, and to the point. Here is, so on the lab notebook sheet, it says it's just a final section. Here's always what I say. You'll hear me say this a lot when it comes to working on lab. The conclusion is, what was the purpose? Did you fulfill it? Why or why not? That's it. So if we write our conclusion, right, I'm going to just look back at the purpose that I wrote in the Prelab, and then I'm going to say the purpose of this lab was to determine the percent Cu in a post penny. That's the first sentence. Usually the second and final sentence is, did you fulfill it? And then tell me why. Be specific as to tell me why. Give me a number or a value or percent error. So I think we fulfilled this. So I'm going to say we fulfilled this purpose. by calculating and I'll put a blank percent CU. So I said, yes, we fulfilled it, and I was specific as to why or how. So I put an actual value in there. Now, I was able to fit the conclusion on the bottom here. First period, when I did it, I had to go to a next page, and that's fine. If you don't have space and you have to go to the next page, then go to the next page. Okay, so the very last thing with lab is before you turn it in. So we are done with the actual lab report itself. All right, we've done post-lab questions, data analysis, conclusion. The very last thing that you have to do is sign and date your pages. This is all you have to do. It's down at the bottom. Right? Don't worry about like the witness and date. That doesn't matter. But where it says signature and date, just sign and then put the date that you turn it in. So each page. So go back to each page, sign, date. Because what that's doing is that's telling me that this is your work, right? You and your lab partner's work. This is considered a professional notebook. And you're just verifying that what you've done is yours. So each page should be signed and dated. Now you're ready to turn it in. So I'm going to show you where you'll turn it in. So when you go to Google Classroom, under classwork, right, because that's where all of our stuff is, assignment 4 is % copper and a penny lab. Whether you want to submit it as a Google Doc, so if you want to take pictures and put them into a Google Doc, you can. If you, some people have like different apps. Somebody's talked about Scannable in first period. If you have an iPhone, your Notes app lets you scan documents and turn it into a PDF. That's what I did with an answer key yesterday. However you want to get your lab report into Google Classroom, whether it's a Google Doc or a PDF. I have a video here creating a PDF using Notes app. So it lets you, I just showed you, it's like a minute. I actually did this for the AP kids last year because that's how they had to submit all of their AP tests. So you can see everything there. I also have the rubric attached into Google Classroom. The last page of the lab handout that you picked up is the rubric. That's how I grade lab reports. Every lab report has a rubric, and I give you the rubric so that you know exactly what I'm looking for. You know exactly how I'm assigning points. There's no surprises. Every lab is graded like that. Now, because we did these labs together, everyone should get a 40 out of 40. So you'll take a picture of each blue page. So you'll take a picture of each page in order. That's what you'll submit to Google Classroom. It's due Friday at the beginning of your class period. I know you're not going to be here Friday. That's just the due date that I made it because usually the day we start a lab, you have 1 week until it's due. So it's just how the time worked out. If you want to turn it in today, you want to turn it in tomorrow, that's fine. But just make sure it's turned in by Friday.